Alrighty, ladies and gentlemen, we're going to start off with some solving quadratics. This is what we did way back in January. When you're going to solve a quadratic, you want to convert it to standard form. So for both of these problems, the first thing I need to do is move everything to one side and figure out when that thing equals 0. So if I subtract 4x, I get 0 on the right side. So both of these problems are starting off with the same thing, and that is 2x squared minus 4x minus 6. So obviously we should get the same answer for both methods, but let's start off with factoring. And when you factor, it's a good idea to find the GCF. So since these are all even, I'll factor out a 2. And then 4 divided by 2 is 2, and 6 divided by 2 is 3. Now I'm focusing only on this trinomial. The 2 is never going to be 0, so it's not a factor when I'm trying to find zeros. So I'm going to find numbers that multiply to -3 and add to -2. Those numbers would be, let's see, 3 and 1, make that negative, we got it. X squared minus 3x plus 1x minus 3. Now I'm factoring by grouping. X minus 3 plus 1, x minus 3. And my factors are x minus 3, x plus 1, and that 2's been on the outside, but again, it doesn't really affect anything. So, when do these factors equal 0? When does x minus 3 equal 0? When x is 3. And when does x plus 1 equal 0? When x equals -1. So to solve by factoring, I've got 3 and -1. And of course, you can go back and check that, plug it in, and you should get 0. Now I'm going to do the same problem, but I'm going to use the quadratic formula. Obviously, I should get the same answers, but let me remind you the quadratic formula in case you don't remember. The opposite of b plus or minus b squared minus 4ac all over 2a. So when I do the quadratic formula, I always focus on the discriminant. The discriminant is the part underneath the square root, the radicand, in the quadratic formula. So let's do that first. We'll do b squared, -4 squared, minus 4ac. Remember, it's ax squared plus bx plus c. So b is -4, c is -6, and a is +2. So now I'm going to go ahead and work through the discriminant, and I'll use my calculator here just to be safe. We're going to get some decimals on some of these problems, but I think this one's going to be pretty friendly. Come on, calculator. -4 squared is 16 minus 4 times 2 times -6, which is 48, and 16 plus 48 makes 64. So the discriminant is 64. And that tells you some things that we'll talk about in a little more, but I know there's going to be two answers, basically. It's positive. Now I'm going to use the quadratic formula here. I'm going to finish this thing up. The opposite of b is 4 plus or minus the square root of 64 over 2a. 2 times a is 4. So what I need to know is what's 4 plus or minus 8 over 4? The square root of 64 is 8, and 2 times 2 is 4. So you can split this up, 4 plus 8 over 4, and 4 minus 8 over 4. So 12 over 4 is 3, and -4 over 4 is -1. Hey, look at that! We got the same answers. X equals 3, and x equals -1. Of course, we should get the same answers. It's the same problem. Moving along, we're going to graph. So, to graph that quadratic, let me see if I can grab that guy. What was it? 2x squared. This guy. Cut. And, oh, maybe I should cut. Oh, no. Maybe I should paste. There we go. So we're going to graph this thing as well. So to graph a quadratic by hand, you need to first find the axis of symmetry, which is the opposite of b over 2a. In this problem, the opposite of -4 is 4 over 2a, 2 times 2. 4 divided by 4 is 1, so the axis of symmetry is x equals 1. That is a vertical line that splits the parabola in half. So we usually draw it as a dashed line because it's not actually part of the function, it's just helps us see our line of symmetry, our axis of symmetry. Then we need to find the y-coordinate of the vertex. It's somewhere on here. I'm giving you an x. I need a y, so I'm going to plug in 1 into the original equation. So 2 minus 4 is -2, minus 2 is -8. You can use your calculator, but the vertex is 1, -8, which is right here. There's your vertex. The x-intercepts are the zeros. But hey, we already found those. They're at 3 and they're at they're at 3 and they're at -1. So That's 3, 0, and negative 1, 0. So I'm going to put a dot at negative 1, 0, and at positive 3. You find the x-intercepts by either factoring or using the quadratic formula. One more thing that we might want is the y-intercept, and the y-intercept is when you plug in 0 for x, so 0 minus 0 minus 6. The y-intercept is 0, negative 6, 1, 2, 3, 4, 5, 6, and I can reflect that point because my points should form, they should be symmetrical about that axis. And then when you draw it, you should try and draw a nice, smooth curve. That's pretty good. It's hard to draw on this thing. Okay, so there's a quadratic by hand. We will need those skills when we do projectile motion by hand. Next up, we are going to talk about coefficients. So we have ax squared plus bx plus c. A determines whether the parabola opens up or down. So if the parabola opens up, a is positive, and if it opens down, a is negative. C is the y-intercept. That's also easy. These are both negative values on the y-axis, so C is negative for both of them. Now the tricky part is, where's the axis of symmetry? So the trick that we oftentimes remember is that when A and B are the same, the axis of symmetry is negative. So if the axis of symmetry is negative, that means it went to the left. A and B are the same. Well, this one has an axis of symmetry that's off to the left, so that means A and B must be the same, which means if A is negative, B is negative. This guy has been shifted off to the right, which means A and B must be opposites. Well, if A is positive, B is negative. The trick, though, again, is that when A and B have the same sign, the axis of symmetry is negative, the entire parabola will shift to the left. Completing the square. Okay, we did some solving by completing the square, but sometimes you'll see these questions written something like this, like what would the c value be to complete the square. The way you figure out what you're going to add to both sides is you take half of b, so divide it by 2, and then you square it. 10 divided by 2 is 5. 5 squared is 25. So in this problem, I'm going to add 25 to both sides. And I would end up then with x squared plus 10x plus 25 on the left side, and on the right side I have 36. And this is easily factorable, which would be x plus 5 squared equals 36. And we could keep going here, but the main question is what would you add to both sides? And the answer to that question is 25. When it says identify the vertex, you should recognize this as vertex form of a quadratic. Vertex form is a times x minus h squared plus k. hk indicates how the function has been, or the vertex of the function. We might remember from family of functions that this has gone right 3 and up 6, so the vertex is at 3, 6. The other way to remember it is h is 3 and k is 6. It's kind of backwards when you see the minus sign on the inside of parentheses. Sometimes people say, oh, it's going to be negative 3. But it's supposed to be x minus h. So it's supposed to be a minus sign. That means they plugged in a positive 3. So the vertex would be at 3, 6. Coming back to the discriminant. The discriminant, again, is the part underneath the square root in the quadratic formula, right here, this guy. So you might remember that when you take the square root of a positive number, you will end up with 2 answers. When you take the square root of a negative number, you will end up with no real solutions. So we'll usually say that there are 0 x-intercepts, so there are none. And if you take the square root of 0, this positive 0 is the same as negative 0. That's not really a thing, so there's only one solution. So there's 2 solutions when the discriminant is positive, no solutions when it's negative, and there's only one solution when the discriminant is 0. That's it for solving. How about using it a little bit? So we did a lot of projectile motion problems. We used Desmos for most of them, but you do have all the skills you need to solve this by hand. You need to recall, though, the projectile motion formula. A is acceleration, and it's usually to gravity. So we usually say it's almost always going to be due to gravity in these problems. The 2 numbers that you see a lot of are negative 9.8 and negative 32. And that's depending on the units. 9.8 is meters per second squared. That's change in speed. And 32 is feet per second squared. That's also, it's per second squared because it's a change in velocity. V sub 0, or sometimes it's read V naught, is the initial velocity. And it will have the same units as whatever you get over here. And H sub 0 is the initial, when 0 time is passed, the initial height. So in this problem, it's the y-intercept. h sub 0 is the y-intercept, which tells you how high the object was when it was initially launched or thrown. We're going to use that now to pick some of those things off. So like the initial height here in this problem is 6, and I know it's going to be in feet because 16 is half of 32. When you do the 1/2 of negative 32, you get negative 16. So anytime you see that negative 16, you know you're working in feet. Initial velocity is that value right there, so that would be 60, and velocity is feet per second. And lastly, the maximum height. Wait a minute, maximum height, that's going to require some work. So to find the maximum height, if you imagine that we're drawing a parabola here, it's going to look like that. I need the maximum height. I'm asking you to find the vertex. So we need to go back to finding the vertex by hand and do opposite of b over 2a, which is negative 60 over negative 32. So I'll bring up my calculator. Negative 60 divided by negative 32. That is 1.875. That means that the firework reaches its maximum height in 1.875 seconds. But we need to figure out the height of the firework, and the way we're going to do that is we're going to plug in 1.875. So negative 16 times, negative 16 times 1.875, that's t squared, plus 60 times 1.875 plus 6, and I get 62.25. So what is the maximum height? The maximum height is 62.25, and we're in feet again, so 62.25 feet. That's right there. That's the y-coordinate of the vertex. How high will the firework be after 2 seconds? So if this is 1.875, it's right about here somewhere. 1.875, it's going to be a little bit below 62, but what I'm really asking you to find is h of 2. I'm giving you a time of 2 seconds. So negative 16 times 2 squared plus 60 times 2 plus 6, and I get 62. So it's only come down a quarter of a foot in those 0.125 seconds, so not very far. That's right there. That's 2 seconds. It's 62 feet in the air. I know the initial height, while I'm thinking about it, is 6 feet, so I'll say 0 seconds have passed. We're at 6 feet in the air. The last thing I want to know is when does it hit the ground? And to do that, we're going to need to do the quadratic formula again. So I'm going to say the discriminant, again, I like to find that first, b squared minus 4ac. So to find the discriminant, I'm going to type in 60 squared minus 4 times negative 16 times 6, which is 3984. And then I'll go ahead and 4, there we go. I'll go ahead and fill in the rest of the quadratic formula, the opposite of b, plus or minus the square root of that discriminant, 3984, over 2a. And that's going to be some nasty decimals when I do the square root of that. So let's go ahead and see if we can work this out. This is 63, let's say 63.12. So negative 60 plus or minus 63.12 over negative 32. 2 times 16 is 32. So I'm going to type this in now, and you got to be careful because if you don't use parentheses for the numerator, you're going to run into order of operations issues. So negative 60 plus 63.12 over negative 32 is negative 0.095. Wait a minute. This thing didn't... Oh, I get it. It's the X-Intercept, but we're not talking about negative time. We don't have a DeLorean. So let's do the same thing now with... That's a Back to the Future joke. Come on. We'll make this a minus sign, and hopefully we find a time that actually means something to us. There we go. About 3.85. So we'll say 3.85 seconds, the height is 0. So in 3.85 seconds, the firework will land on the ground. It's launched from 6 feet. It goes up in 1.875 seconds. It hits its maximum height. At 2 seconds, on its way down, it hits 62 feet. And then at 3.85 seconds-ish, it lands on the ground. So all of these are things that we have done by hand. I did it up here, but now we're doing it for a projectile motion problem. Let's solve some systems of equations now. So to solve systems of equations, if you have two outputs, you want to set them equal to each other. X squared plus 8x equals x minus 6. Now, this is a quadratic, so just like I did in Unit 1, I'm going to get everything on one side. So minus x plus 6, set it equal to 0. I have x squared plus 7x plus 6. So now we need to factor to solve this quadratic. Or you could use quadratic formula, but I'm going to factor. I'm going to find numbers that multiply to 6 and add to 7. It's 1 and 6. All right, so when I split the middle, x squared plus 1x plus 6x plus 6, and I still want to know what equals 0. I'm finding the GCF of each half, so x plus 1, plus 6, x plus 1. And that means my factors are, hey, that's the same, that's a good sign, x plus 1 and x plus 6. So that means that x either equals -1 or x equals -6. Now, this is a system of equations, so what I'm really trying to find is where these points intersect. I have the x-coordinates of where they intersect, but I want to find the y-coordinates of where they intersect. So to do that, I'm going to plug -1 in to either of these equations. Clearly, I think this one's easier. So if I plug -1 in, -1 minus 6 is -7. And if I plug -6 in, -6 minus 6 is -12. That means that when the x-coordinate is -1, the y-coordinate is -7. And when the x-coordinate is -6, the y-coordinate is -12. These are the points of intersection for this quadratic and this line. And if you graphed it, you could use Desmos to check it, at least for the practice. You'll find that they intersect at -1, -7, and -6, -12. You can also check it algebraically by coming up here and plugging it into the other one. If I plug -1 into the first one, plus 8 times -1, I should get -7. And if I plug -6 into the first one, -6 squared, plus 8 times -6, I should get -12, and I do. So you can check it algebraically, or you can check it graphically if you have the ability to graph it. We'll solve another system of equations. These are two linear equations, so I don't need to set them equal necessarily. I could use substitution, or here I'll try elimination. So when you do elimination, the goal is to get rid of one of the variables. If I make all of these negative, so multiply everything by -1, then that cancels out. 3x minus 2x is 1x, and 8 minus 6 is 2. I did it in one step. X is 2. I still need to go back and plug in to get y, so I'm going to take that x and I'm going to plug it in. It probably doesn't matter which one I pick, 8. So then I've got 6 plus y equals 8, and when you subtract 6 on both sides, you get y equals 2 as well, which as an ordered pair, x is 2, y is 2. That's where these two lines will intersect. You can check it algebraically by plugging it back in and making sure that it equals 8. 6 plus 2 is 8. And 2 times 2 plus 2 is 6. 2x plus y. Yeah, 4 plus 2 is 6. Great. So it works algebraically. Or, again, you could graph it if you have the means to graph it. Tell whether an ordered pair is a solution to a system. So if it's a solution to the system, just like back here, that means it satisfies both equations. If I plug 8 in for y and 0 in for x, it should make a true statement. And it has to work in both, so if I plug in 8 for y and -2 times 0, that should make a true statement. If it works in both, then it's called a solution. So is 8 greater than or equal to 2 times 0? 0 plus 6? Yeah, that works. Is 8 less than -2 times 0 is 0? 0 plus 3 is 3. Wait a minute. 8 less than 3? Nope. Since it doesn't satisfy the second equation, then this is not a solution to the system. So you can say, no, it's not a solution. Not a solution to the system. Okay, we'll try the same thing here with -5, 2. So 2 is greater than or equal to 2 times -5 plus 6. And in the second equation, -5, no, y is 2. 2 is less than -2 times -5 plus 3. So now, is 2 greater than or equal to -10 plus 6? Is 2 greater than or equal to -4? Yeah, sure is. Is 2 less than 10 plus 3? Is 2 less than 13? Yep, sure is. So this is a solution. That means that if I were to graph it, it would be in the overlap between these two inequalities. Or algebraically, as we've seen, it satisfies both equations. One more. Is 4 greater than or equal to 2 times 3 plus 6? Is 4 greater than or equal to 6 plus 6? Is 4 greater than or equal to 12? No. If it doesn't work in the first one, I don't need to try it in the second one. This one is not a solution. Okay? Not a solution because it doesn't work in either, well, it might work in the second one, but it definitely doesn't work in the first, so we're done. To graph an inequality, we're going to treat this like a line. I'm going to start at the y-intercept, 1, 2, 3, 4, and I'm going to count the slope, down 2 over 3, down 2 over 1, 2, 3, down 2 over 1, 2, 3, and up to left, up to 1, 2, left 3, up to left, 1, 2, 3, and I've got a line, which is a solid line because it's a less than or equal to. If it was a just less than, I would use a dashed line. And then the last thing I need to do is decide, should I shade up or down? Now, it's a less than, so you can shade down, but the other way to test it is pick a point. Like if I try, I like to do 0, 0. If I plug in 0, 0, does it make a true statement? Is 0, 0 a solution? Is 0 less than or equal to 4? It sure is. So since this point works, all the points on this side will be shaded in. None of the points on this side will be shaded in because none of the points on that side of the line work. Alright, we've made it through a couple units now. Let's see if we can do some stats. Now, on the final exam, you will not have to generate this data because you won't have Desmos, but you will have to maybe use this data. So if I give you this information, can you do all the things that you need to be able to do with it? So when it says construct a normal curve, drawing a normal curve always is the same. Let's see, that's, oh, I did a good job until the end. I choked. One more try. Alright, that's probably as good as it's going to get. So, hey, look at that. It looks better now. Okay, when you draw a normal curve, you're going to put the mean in the middle. So in this problem, the mean is 54.6. So this is 54.6. Okay, sometimes you draw like a line to kind of help you find the middle. We move that guy over a little bit. There we go. That's better. Now, what we're trying to do is add and subtract standard deviations from the mean. So if I do 54.6, and I want to add one standard deviation, that would be plus 13.1, which is 67.7. So this I'm going to label 67.7. I'm going to do that two more times, 80.8 and 93.9. 80.8 and 93.9. I'm running out of space here. I could probably stretch that out. But I'm going to do the same thing, 54.6 minus, well, I'll kind of do this a little easier, minus 13.1. And I'm going to do that three times. 41.5, 28.4, and 15.3. So 41.5. The other one was 28.4. And then lastly was 15.3. Again, I can stretch this out a little bit. But we have what's called the empirical rule. And the empirical rule tells you how many, or what percentage of the data you should expect to see between one standard deviation of the mean, between two standard deviations of the mean, and between 3 standard deviations of the mean. If it's normally curved, we should expect to see 68% of the data between one standard deviation of the mean. So that would be 41.5 and 67.7. Similarly, 2 standard deviations of the mean right here and there, 28.4 and 80.8. We should expect to see about 95% of the data in that range. And then lastly, 99.7% of the data you see should be between 3 standard deviations of the mean. So that's 3 standard deviations below and 3 standard deviations above the mean. So that's called the empirical rule, and sometimes you hear 68, 95, 99, 7 rule. Next up, we're going to see if we can find any outliers. I don't have the data, so I'm not sure how I'm going to do that. But let's find the fences anyway. The IQR is Q3 minus Q1. So Q3 is 64, and Q1, that's a 6, minus 43. So 64 minus 43 is 21. The IQR is 21. We need that because to find the lower fence, you take the first quartile and you subtract 1.5 of those IQRs. IQR. So I need to take Q1, 43 minus 1.5. That IQR is 21. And I can go ahead and use my calculator here just to be safe. 43 minus 1.5 times 21 is 11.5. And I'll do the same thing, very similar up here, but you start at Q3 and you add 1.5 IQRs. So Q3 is 64 plus 1.5. The IQR is still 21. So when I do the same thing, 64 plus 10.5, 1.5 times 21 is 95. Okay, it's not 10 and a half, it's 10 and a half in addition to 95.5. So, the lower fence tells you outliers on the low end. So any numbers that were smaller than 11.5 would be an outlier, and any numbers larger than 95.5. Now, I don't have the data, so I can't actually tell you outliers, but any number smaller than 11.5 or larger than 95.5 would be considered an outlier. Since I don't have the data, I can't actually tell you if there are outliers, but I can give you the range of numbers. Any number outside of these fences is considered to be a statistical outlier. What if I give you a box plot? Can you tell me the min, max, median, and quartiles? Well, you should. This guy's the min, and it looks like I'm counting by 2's here. That's 25. So the min is 25. Let's do the max. The max is 48. The median is the middle of the box plot. So the median in this problem, that looks like it's about 33. The median is 33. Then the quartiles are right here and right there. This is Q1. Q1 looks like it's at 29. Q1 is 29, and Q3 is 37. Okay? You can also call the median quartile 2. It is the 50th percentile, so that would also work. But we normally just call it the median. So we're done with stats. We're cruising. How about family of functions? Okay, family of functions, you need to remember there were a few functions we graphed and we shifted around. Absolute value is one of these guys. It's a sharp V. All the numbers that have an absolute value of, let's say, 5 are, that would be 5, or negative 5 also has the same absolute value. So absolute values are this sharp V. It's like a line that's been bounced off the origin. X squared, that's a quadratic. So quadratics are that smooth curved parabola. We've done a lot of quadratics in here. It's not the best quadratic, but that's what a quadratic kind of looks like. And lastly, the square root of x, or radical x, that's a parabola on its side. It's been kicked over and cut in half so that it passes the vertical line test and is still a function. So a square root should look like a parabola on its side. So how would I move an absolute value to the right 6 and down 4? Well, let's start with an absolute value. And to move an absolute value right 6, we're going to go minus 6 on the inside. It's kind of backwards. When you see a minus sign, it goes to the right. And to move it down 4 on the outside, we're going to subtract 4. So if I said this is f of x equals the absolute value of x minus 6, that would move it right 6, and then minus 4 moves it down 4. How would these translations work? If this is x plus 6, that makes it go left 6, and on the outside we have minus 2, so that makes it go down 2. So left 6, down 2. That would be a radical. And here's a quadratic that has gone to the right 2 and up 6. That's called vertex form. We talked about that earlier. Modeling with regression, we're estimating R values. This is definitely not something we can accurately do. We would need some technology, but we can kind of eyeball it. I think these are the same thing. I'm not sure what happened there, so let's cross that one out. This, to me, doesn't have a whole lot of correlation here, actually. I'm not sure that there is a correlation, so I'd say the R value is probably like 0. Okay, I can't tell you if it's going to go up, or it's going to go down, or it's horizontal. It's all kinds of over the place, so I don't think there is a correlation between those two. This guy, though, if I look at him, like, I can see that there's a trend. So there's a relation between x and y, and it is decreasing. So it's negative, and it seems like it's not 1. 1 would be perfect on this line. Let's say it's like negative 0.9, negative 0.8-ish sometimes. Somewhere in there, probably. It's a pretty decent correlation. There's definitely seems to be a trend. So I just say like negative 0.8, negative 0.9. Something close to negative 1. Negative 1 is perfect. Now we'll say, are these exponential, linear, or quadratic? I think they're in that order, actually. This, to me, looks like it would be an exponential function. Exponential functions have a horizontal asymptote, so they start off really slow, and then they pick up steam. So this is an exponential function. This guy looks to me like it's just a linear function. I think that's the one we just did, so I'd say that's linear. And then this third one appears to be negative upside down quadratic, so I think that would be a quadratic. Now, this is one of those things where we could probably model these if we had the data, and I can tell you about R squared values, but we don't have the data, so I'm just kind of eyeballing. I'm saying, it's probably quadratic, it's probably linear. There might be a really good parabola that actually hits these. We just don't see the rest of the graph. Same thing here. There might be a really good parabola that hits this data. We just don't have the data to verify our answers. All right, Unit 7, radicals. This should be pretty fresh in your head. We just tested this. So first thing, if you see that these are all radical 5s, these are called like terms. These are like radicands. They all have the same radicand. So if you have 7 radical 5s and you add 4 radical 5s, you have 11 radical 5s. And if you subtract 3, then you have 8 radical 5s. Well, these are not like radicands, so you can't do that. But I could say 5 radical 3 minus 2. 12 is not prime. 12 is 2 times 2 times 3. So you can actually reduce and simplify that radical to be, this is the square root of 4, the square root of 4 is 2, so that 2 is coming out. Now you have 4 radical 3. Wait a minute! 5 radical 3s minus 4 radical 3s is 1 radical 3. Let's play that same game here. I'm going to factor 128. 128 is 2 to the 7. 2, 4, 8, 16, 32, 64. It's 7 2s. X, 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 Y, Y. Okay. Take some computer science classes. You'll learn your powers of 2 real quick. Pair of 2s, pair of 2s, pair of 2s. That's 2, 4, 8. So an 8's coming out. Also, we have a pair of X's and a pair of Y's. So an X can come out and a Y can come out. What's left underneath? I got a 2 and I got a single X. I know there's going to be one left because that's odd. So 8xy radical 2x. Last radical to simplify. This is a quantity squared. You cannot distribute exponents. Please don't ever do that. Your math teacher is just, you just hear this. That was my head hitting the table. So we're going to write this out. Radical 2 plus 2 and radical 2 plus 2. Because you need to FOIL, ladies and gentlemen. Radical 2 times radical 2 is radical 4, which is 2. Radical 2 times 2, well, it's just 2 radical 2. And again, 2 radical 2. And then, lastly, 2 times 2 is 4. So we'll combine like terms. 2 plus 4 is 6. And if you have 2 radical 2's and you add 2 more radical 2's, you have 4 radical 2's. So that's 6 plus 4 radical 2. What else we got? Solving? Okay, I can solve a radical equation. First thing, isolate the square root. Check. Square both sides. Nice. X squared equals 5x minus 6. Okay? Now we're solving a quadratic, so you have to get everything on one side. I'm going to subtract 5x, and I'm going to add 6. Now I need to split the middle, so I need numbers that multiply to 6 and add to negative 5. Be careful here. It's not 6 and 1. It's x squared minus 2x and minus 3x. Okay, we're going to need to get this guy out of the way. Then I can split the middle. X, I've already split the middle. I'm going to factor x minus 2. So be careful, that's a minus sign, so you're actually factoring out a negative 3. And then we have x minus 2, x minus 3 equals 0. And I got x equals 2 and x equals 3. So do I have 2 solutions to this? Maybe. With these problems, you need to definitely go back and check them because they might satisfy this quadratic that I solved, but they might not solve the original equation. They're called extraneous solutions. So I'm going to take 2 and plug it in, and I'm going to see if it makes a true statement. Is 2 the square root of 10 minus 6? Is 2 the square root of 4? Yeah, it sure is. Is 3 the square root of 5 times 3 minus 6? Is 3 the square root of 15 minus 6? Is 3 the square root of 9? Hey, it sure is. Hey, there's 2 solutions. Cool. Sometimes there's 2 solutions. Sometimes there's no solutions. Sometimes there's 1 solution and an extraneous solution. You just have to work backwards and make sure you check your answers. Last one I'll solve. Oh, just find the domain. Find the domain? Okay. So the problem here is you can't square root a negative. So what we do is say, hey, radicand, you can't be negative. You got to be greater than or equal to 0. And then we isolate x by subtracting 3 on both sides, and I have x is greater than or equal to negative 3. That's the domain. You can't graph, like if you're going to make a table here, you start at negative 3, but you try and plug in negative 4, and you're like, oh wait, that's the square root of negative 1, that ain't going to work. So the first real number you're going to get is when you start with x equals negative 3. Last thing we got to be able to do is piecewise functions. So we're going to use the same graph for all 3 of them. Write the equation for the linear piece. So you want to kind of look at it and see if you can figure out what's the y-intercept, what's the slope. Looks to me like the y-intercept is 3 and the slope is down 1 over 1 to down 1 over 3. So then the slope would be that down 1 over 1 2. Yeah. So the slope is negative 1/3 and the y-intercept is 3. So to write the equation, we'd say negative 1/3 x plus 3. That's the equation for the linear part of it. I don't know the equation for the quadratic, but that's okay. What else do we need? Find the domain. Okay, the domain is the x value. So if you look here and you look here, this thing has been chopped off. The ends have been chopped off. So the minimum x value is 0, and the maximum x value is 1, 2, 3, 4, 5. It's kind of hard to read. What also is going on here is you have an open circle and you have a closed circle. So we say 0 is less than or equal to x is less than 5. And the reason that we have a less than or equal to is because it's a closed circle. And the reason we have a less than and not less than or equal to is because it's an open circle. It can't actually equal 5. Because if it equals 5, guess where it's going to go? Up here, in that closed circle. Which, hey, that's one of the questions I'm going to ask you now. F of 3. So if I come over here and I say, where is x3? This is where x is 3. What's the y value right there? The y value there, right there would be 2. So f of 3 is 2. And I also need to find f of 5, so I'm going to kind of play the same game here. I'm just imagining a vertical line where x is 5. You're like, wait, do you pick the open circle or the closed circle? Well, that comes from what they mean. The closed circle is when you have a greater than or equal to 5. So this, since 5 is equal to 5, then we're going to choose this piece of the function, and we're going to say its y value, and its y value is positive 2.5. So, we did it. That's an entire semester. It's a lot of work. So go through the crash course. You're good. You've got your practice final to work on. You've got your other study guides to work on. Guys, you got a lot of content to cover. Hopefully that helps. Good luck on your finals. And we're almost there, guys. It's almost summertime. So I'll see you.